Hello everyone. Today we'll be solving Cambridge IGCSE Chemistry Paper 2 Multiple Choice February-March 2020 Variant 2-2. In this particular video, we'll be solving from question number 1 to question number 20 in our part 1 video. And in the part 2 video, we'll be solving from question number 21 to question number 22. So keep an eye for that. Question number 1. The formula of methane is CH4 and the formula of ethane is C2H6. Which row describes diffusion and the relative rates of diffusion of methane and ethane? When discussing diffusion for methane and ethane, we need to know relative molecular mass of methane. For methane, it will be 12 plus 1 into 4, 16. For ethane, it will be 12 into 2 plus 1 into 6. So it will be 24 plus 6, 30. So anything with lower molecular mass, lower MR, diffuses faster. So we'll have to keep that in mind. And now, description of diffusion. Particles move from a high concentration to a low concentration. All right, so correct, this is correct. Particles move from a high concentration to low concentration. Part B also has particles move from high concentration to a low concentration. All right, so both are correct. And in C, particles move from a low concentration, so wrong. Okay. Now, the next portion, relative rate of diffusion. Ethane diffuses more quickly than methane. So we already see that lower MR diffuses faster. So ethane has a higher MR. We can see that it has a higher MR. It has an MR of 30. So it cannot diffuse faster. So this is also wrong. So the only possible answer will be B. Part 2. Which test is used to show that a sample of water is pure? Okay. If we want to show that a sample of water is pure, the best procedure will be, freezing point, melting point. All right. So melting point. All right, or we can try boiling point. So now the question says, evaporate the water to see if any solid remains. Not a good way. There can be contaminants. Those can also evaporate with the water. For example, water and alcohol both can be present together, and alcohol will also evaporate away from water. So we can't actually tell that. Heat the water to check its boiling point. Definitely, checking boiling point is the best method. Test with anhydrous cobalt 2 chloride. Well, testing with anhydrous cobalt 2 chloride only gives us the test for presence of water. This test, remember that this is only for presence of water. So definitely cannot be used as an indication for purity of water. Use universal indicator paper to check its pH. We know that pure water has a pH of 7. However, many things can have pH of 7. So not a good way of doing it. So we can also cross this particular method out. So definitely B is the correct answer. Question number 3. Chromatography is used to separate and identify the components in both colored and colorless mixture. For colorless mixture, the chromatogram has to be treated with another chemical. So this another chemical is often called the locating agent, because we use this to locate where our particular chemical, those that are traveling through the chromatography, where they have traveled up to. So what is the name of the type of the chemical? So obviously it is not a coloring agent. We already said not a display agent or finding agent. It's called the locating agent. Okay. So question number 4. Lithium reacts with fluorine to form the compound lithium fluoride. Which statement about this reaction is correct? Each fluorine atom gains 1 electron. All right. So we can see lithium, when it reacts with fluorine, it produces lithium fluoride. Now, in terms of lithium is a metal. When it reacts with fluorine, it produces Li plus F minus. So definitely fluorine has gained 1 electron. So which statement about this reaction is correct? Each fluorine atom gains 1 electron. This is correct. Now the next statement, each fluorine atom gains 2 or more electrons. No, they only can gain 1 electron. I'll explain why a fluorine will get 1 electron. Fluorine has a proton number of 9, electronic configuration of 2, 7. So in order to become 2 8, it only requires one more electron. So if we just add one more electron, it will become 2 8. So there is no need for two electrons. Okay. Now each fluorine atom loses one electron. We already see that fluorine has 7 electrons in the outer shell, so definitely it will not want to lose an electron. Each fluorine atom loses 2 or more electron. Definitely not. So A is the correct answer. Carbon 14 and carbon 12 are isotopes of carbon. Which statement about these isotopes are correct? Okay. Now the question says carbon 12 is more reactive than carbon 14. One thing we must understand, isotopes have similar chemical reaction. Similar chemical reaction. Now, the reason why isotopes will have similar chemical reaction, because it is the outer shell electron that determines the chemical reactivity. Since both carbon are going to have the same number of outer shell, regardless of it being carbon 14 or carbon 16, it will still have 2, 4 electronic configuration. So both of them will react in the same manner. C12. So point number A, definitely wrong. C12 is more reactive than C14 because the atoms have different number of neutrons. Well, there is different number of neutrons, but we already talked about it. It cannot be more reactive. The reactions of C12 are similar to C14 because they have the same number of outer shell electrons. Guys, we already explained this particular point of outer shell electron, and point C happens to be a correct point. Okay, let's see number point D. The reactions of C12 and carbon 14 are similar because they have the same number of protons in the nucleus. As we have already discussed, the number of protons within the nucleus does not determine the chemical reactivity. So it is only the outer shell electron that determines chemical reactivity. So C is a correct point. Guys, as a note point, I'm writing down only outer shell electron determines chemical reactivity. Moving on. The molecular structure of hydrazine N2H4 is shown. We can see the molecular structure of hydrazine. Which description of the bonding in hydrazine is not correct? All right. So which description of the bonding in hydrazine is not correct? Okay. The question says each nitrogen atom has a non-bonding pair of electron. Every nitrogen belongs to group 5 and it has total of 7 proton number, 7 electrons. So 2 5 electronic configuration. So definitely if 3 electrons are used in bonding in 3 sites, there will be definitely 2 left as lone pair in each nitrogen. So that being said that it is there. So each nitrogen has non-bonding pairs of electron. Yes, they have. This is the correct statement. However, we want the not correct one. So this is not our statement. So we'll cross it out. Each nitrogen atom has 4 bonding pairs of electron. Now that we can definitely confirm that there is 1, 2, 3. 3 bonding pairs of electron. This is definitely not correct. And since our question wants not correct, so this is our right answer. Let's see the other points. Each nitrogen atom shares one of its electron with a nitrogen atom. So we can definitely see each nitrogen in the hydrazine, they are bonded with another nitrogen, which we can see. So definitely that is a correct statement. So not correct. Each nitrogen atom shares 2 of its electron with hydrogen atoms. Yes, that is also correct. Each nitrogen is sharing 2 of its electron with hydrogens. So we'll also cross this out. Number B will be the correct answer. Guys, question like this where it says not correct can be very difficult and tricky. Because if you say that this point is not correct, then yes, it is not correct. However, it is a correct statement. So that makes it really difficult. So I would definitely ask you to be careful when reading this particular question. Question number 7. Solid X has a high boiling point. Its structure has a positive ion surrounded by a sea of electrons. Which other properties does solid X have? Good. Solid X, it's a solid. All right. It has a high boiling point. All right. And when it is a solid, all right, its structure is surrounded by a sea of electrons. Typically, this is a properties of metal. So if we want to know other properties of metal, metals are not brittle. So it says, first point says brittle and electrical conductor, brittle and insulator. So metals are not brittle. So we definitely know that. So next is, we know that metals are malleable. So metal must have a malleable character. So C and D has malleable character. Metals are not an insulator. So definitely wrong. Metals are a good electrical conductor. So C is the best answer for this one. Guys, moving on to question number 8. The formula of some ions are shown. We can see Al3 plus, Cl minus, Fe2 plus, 3 minus. Which row is the formula not correct? For aluminium oxide, we can see Al2O3, which completely makes sense. Al is 3 plus and O is 2 minus. So if we exchange the number, it will be Al2O3. For iron 2 nitride, Fe2N3. So let's see for this one. For iron, Fe2 plus and nitride N3 minus, if we exchange the number, it is going to be Fe3N2. So guys, we can see this is wrong. All right, let's see for sodium sulfate. For sodium and sulfate, obviously it's going to be, we're going to exchange the number Na2SO4. For zinc nitrate, we can exchange the number ZnNO3. All right, so obviously that is going to be ZnNO3 will give a bracket and 2. So we can see all of the rest of them are correct, and only Fe2N3 is wrong. So we are looking for the one which is not correct. So definitely B is our correct answer. Question number 9. The equation for the decomposition of magnesium nitrate is shown. When magnesium nitrate is decomposed, it turns into magnesium oxide, nitrogen dioxide, and oxygen. All right, now the question says, which volume of gas is produced when 0.1 mole of magnesium nitrate is decomposed completely? I like questions like this. These are a little bit tricky, guys. However, we have to understand, whenever we have a equation that is already in place and balanced, we have every information that we need for solving a question like this. This question already tells us that if we have 2 moles of magnesium nitrate, we are going to get 2 moles of magnesium oxide, and we are going to get 4 moles of nitrogen dioxide, and we are going to get 1 mole of oxygen. Now, if we convert that same thing, let's say we start with 0.1 mole of magnesium nitrate, definitely we are going to have 0.1 mole of magnesium oxide, because they are 2:2 ratio. All right. However, since it is 2:4 ratio, so we are going to have 0.2 moles of nitrogen dioxide, and we are going to have 0.1 divided by 2 moles of oxygen, because it's a 2:1 ratio. You can see there is nothing in front of it, meaning there is 1. So 0.1 divided by 2. Now the question says, which volume of gas is produced when 0.1 mole of magnesium nitrate is decomposed completely? We can definitely say we get 0.2 moles from here. So let's add up 0.2 and 0.1 divided by 2, which is equals to 0.05. So we get 0.25 moles. Now, in this situation, we'll have to just simply multiply it with 24 to find out the volume. 0.25 multiplied by 24 is going to be 6 dm cube. So question number 9, C is the correct answer. Guys, I hope you understood how to solve questions like this. Often students are very scared of answering this type of question. Please repeat this particular video one more time and see how I have done it. I will solve many more questions to come. So in those particular questions, all the moles related questions, I'm gonna explain to in depth and details. Watch all of the videos. My plan for this upcoming question paper, examination, my plan is to upload all the 2 variants. At least I'll upload 10 question papers in total of 20 videos. So let's see, best of luck to me and best of luck to you guys. All right, so moving on, guys. Question number 10. Which statements about the electrolysis of molten lead to bromide are correct? Okay, so we are electrolyzing molten lead to bromide. We can already see that the Pb is in 2+, the lead is in 2+, and the bromide is in Br- oxidation state. Now, the question says lead ions move to the anode. Okay, now you got to understand what is an anode. An anode is a negative electrode. All right, sorry, anode, my bad guys. Anode is a positive electrode. It is a positive electrode. So whenever the statement says that lead ions are attracted, they move to the anode, the statement is already wrong, because a positive will never move towards a positive. And the name anode comes from anions. Anions are negatively charged ions, and anions are attracted towards the positive electrode, which is logic, which is definitely a good logic. All right, so number one is already wrong. When number one is wrong, I can already see A is wrong, B is wrong. So I can just simply cross them out. I know that they're not going to be the answer because number one is wrong, they're not going to be the answer. Now I can see point number two is both common in C and D, and thereby I can already say that that point is going to be correct, and probably you'll find it correct too. So first of all, lead ions move to the cathode and are reduced. Okay, so this part of moving toward the cathode is very clear. If anode is positive, cathode is, guys, obviously cathode is negative. Now, if cathode is negative electrode, so what it's going to attract? Definitely is going to attract the Pb2 plus towards itself. Definitely. Now, what the rest part of it says that they are reduced. Obviously, when Pb2 plus gains 2 electron in the cathode and turns into lead metal, it is reduced. So we can see reduction. Definitely this is a reduction. All right, so lead ions move to the cathode and are reduced. This is a correct statement. All right, now we have to decide between point number 3 and point number 4. The third statement says bromide ions move to the anode. All right, and then the fourth statement says bromide ion moves to the cathode. So definitely, you see, bromide is a negative ion, cathode is a negative pole. It is never going to attract each other. So this point number 4 is wrong. So if point number 4 is wrong, we can already get our answer, which is C. Bromide ions are moving towards the anode and are oxidized. Now you might have a question that how is it oxidized? Okay, for that particular part, when we have 2Br minus, it turns into bromine and it gives off 2 electron. When we have 2Br minus, it turns into bromine and it gives off 2 electrons. So what we have to do in terms of calculation here, if you look into it, if it is losing electron, definitely that is getting oxidized. So that part is also explained. So 2 and 3 are correct statement, and thereby C is the correct answer. Question number 11. Guys, moving on. Aqueous copper to sulfate is electrolyzed using carbon electrodes. Which statement is correct? All right, guys. Now, obviously, for this particular calculation, I will require some space. I will erase all of these, guys. You can just pause the video from the previous part, and then basically you can solve it from there. I need the space to show you the working. Guys, let's see. Bubbles of hydrogen are formed at the anode. Now, what do they mean by that? Okay, let's see if we were to set up the electrolysis of copper to sulfate, we are going to use carbon electrode according to what they have told us. All right, so this is the negative, this is the positive. We have copper sulfate solution, and here we have copper sulfate solution, and here we have carbon electrodes, positive and negative, or we have CuSO4 here. Okay, now they said bubbles of hydrogen are formed at the anode. Anode is the positive pole. All right, anode is the positive pole. Positive pole is the anode that we have already discussed. Now, if positive pole is anode, definitely it is never going to attract hydrogen ion towards the anode. So this is a false statement. Bubbles of hydrogen are never formed at the anode. Bubbles of oxygen are formed at the cathode. Now, on that particular regard, in this particular copper sulfate solution, we also have, along with copper sulfate, the ions that are present is copper 2 plus, sulfate SO4 2 minus, which is from the copper sulfate. We also have aqueous, means we have H plus and we have OH minus. Now, according to the reactivity series, we know that sulfate cannot be released from aqueous solution. So we'll just cross it out. All right. Now, for the hydroxides, which can be released, we know that 4OH minus produces 2H2O, all right, 1O2, and gives up 4 electron. So definitely this is negative ion. Now, negative ion will never go towards the cathode because the cathode is negative pole. So negative ion will never go towards the cathode. So oxygen Bubbles of oxygen are formed at the cathode is also a wrong statement. Next point, copper is deposited at the anode. All right. So when talking about copper being deposited at the anode, guys, we have to understand the reactivity series from copper and hydrogen. Between them, copper is lower in the reactivity series, so copper is definitely going to be released. However, copper is a positive ion, cannot be released into a positive pole, so wrong. Now the next question says the blue color of the solution fades. Now guys, this is true because the copper in the solution, which is responsible for the blue color, accepts 2 electrons and goes into the cathode and gets deposited as copper metal. The color will eventually fade. So D is the correct statement. Guys, question number 12. Nitrogen fluoride is used to manufacture of certain types of solar panels. The equation for the formation of nitrogen fluoride is shown. When nitrogen is reacted with fluorine, it produces nitrogen fluoride. Type of bond, there are N and triple bond. Bond energy, 950, FF 150, NF 280. Using the table of bond energies, what is the energy change for this reaction? Guys, in a question like this, I would always suggest, if you have a little bit of time, break this down into the bonding that they have and then visualize it. Because if you break it down in the bonding that they have and then visualize it, you will be able to see all the bonds. So we can see there is one NN triple bond, 3 FF bond, but on the other side we have 6 NF bond, which was almost going to be missed if we didn't do it in this manner. So NN triple bond is 950. We'll just simply add. And fluorine, which is 150, we're going to multiply it with 3. When we do that, then we get the bond broken. Then bonds formed is 6 into NF, which is 280. All right. So that adds up. Let's see the calculation. So guys, we can see that the bonds breaking energy is 1400, and bond breaking energy is 1400, and bond forming energy is 1680. So if we do the subtraction, 1400 minus 1680, we are gonna get 280. So minus 200, negative 280 kilojoule per mole will be the energy. So energy will be released in this particular reaction. Question number 12B is the correct answer. Question number 13. Which statement about the hydrogen fuel cells are correct? All right. So about hydrogen fuel cells, the reaction between hydrogen and oxygen is endothermic. Guys, we know that the reaction and between hydrogen and oxygen is exothermic. So we can understand that this is a wrong statement. One is wrong. If one is wrong, A and B both are cancelled. We can see we find ourselves in the same position. We have option 2, 4, and 3 and 4. So both options will have 4 as correct. So let's see the point number 4. A hydrogen fuel cell is used to generate electricity. Definitely, we can generate it to produce electricity. Definitely. All right. And then point 2 and 3. For point 2, the waste product in a hydrogen fuel cell is water. So yes, a hydrogen fuel cell, when it operates, hydrogen reacting with oxygen only produces water. So definitely it is water. Now the question says which use about hydrogen fuel cells are correct. We can see point number 2 and 4 are correct. So C is correct. Now for point number 3, why point number 3 is wrong? Let's see. A chemical reaction in the cell produces hydrogen, which is used as the fuel cell. Now, which is used as the fuel. So obviously no, we do not, it doesn't produce any hydrogen inside the hydrogen fuel cell. All right, okay. Question number 14. Which change is a physical change? Copper to carbonate changes color from green to black when it is heated and stays black when it is cold. Now, copper to carbonate changing color from green to black when heated and staying black after it cools is a chemical change. So this is a chemical. So definitely this is wrong. Ethanol reacts with oxygen to produce carbon dioxide and water, also chemical. So thereby wrong. Hydrogen peroxide decomposes into water and oxygen, also chemical. All right. When it is boiled, okay, but still it is chemical because we are forming new compounds out of hydrogen peroxide. And ice forms liquid water when it is heated. Definitely, this is a physical change. We can again freeze the water. We can take the heat energy away from the water and it will solidify into ice. Question number 15. A student adds excess magnesium ribbon to 10 cm cube of 0.5 mole per dm cube sulfuric acid. The hydrogen gas is collected and its volume measured every 10 seconds. The experiment is repeated using the same mass of magnesium ribbon, 5 cm cube of 0.5 mole per dm cube sulfuric acid added to 5 cm cube of water. Okay, which graph show the result of the second experiment? Guys, in the first experiment, we had excess of magnesium ribbon. So if we have excess of magnesium ribbon, meaning mass of magnesium is never the limiting factor for this particular reaction. However, we had 10 cm cube of 0.5 mole per dm cube sulfuric acid. So in terms of quantity, we have halved it here. We have half the quantity of the original one. If we have half the quantity, we're going to get half the volume. We added 5 cm cube of water, which dilutes. We added 5 cm cube of water, which dilutes the experiment, obviously. So now we have to understand in terms of reaction when hydrogen reacts with sulfuric acid. Sorry, when magnesium reacts with sulfuric acid. So for magnesium reacting with sulfuric acid produces magnesium sulfate and hydrogen. We can see that this is a pretty straightforward reaction. It has a 1:1 ratio. Now, here 10 cm cube, all right, divided by 1000 into 0.5 mole per dm cube, we're going to get the quantity of the sulfuric acid used. So 10 divided by 1000 into 0.5. We get 5 into 10 to the power of minus 3 moles of H2SO4. Whatever the number of moles of H2SO4 will also be the number of moles of hydrogen, because there is a 1:1 ratio. So the number of moles of hydrogen is also 5 into 10 to the power of minus 3 mole. Now we need the volume of hydrogen. So volume of hydrogen, volume of H2 will be number of moles 5 into 10 to the power of minus 3, all right, into 24,000. Into 24,000. So that produces 120 cm cube. Now 120, definitely that is, we can see this is the original experiment represented here. The original experiment represented over here finishes at 120. Using a lower concentration, because we are adding 5 cm cube of water to fill up that particular 10 cm cube volume, will slow the rate of reaction. So C will be the correct answer, because it reaches the same height, but it is a slower rate. Guys, this particular calculation wouldn't be necessary. I just did it for to show you that how we came up with the calculations of producing 120 cm cube. Since we are using in the second experiment, we are using 5 cm cube, we are using half the quantity. So our volume will be half of that. So half of 120 will be 60 cm cube. So D will be the correct answer. Guys, moving to question number 16. An equilibrium reaction is shown. N2O4 gas turning into 2NO2 gas. The forward reaction is endothermic. So we will write it down. This is endothermic reaction. Guys, it is always a good idea to also write down that the reverse reaction is exothermic. Always it's a good idea to write what is the reverse reaction. It is always going to be the opposite of the forward one. What is the effect of changing the temperature and the pressure on the equilibrium position? Increasing temperature. Now we know in an endothermic reaction, increasing temperature has an effect of producing more product. So equilibrium shifts to the right, moves to the right. It cannot move to the left. All right. So increasing temperature moves to the right. Increasing pressure. We can see there is 1 mole in the left hand side and 2 mole on the right hand side. Increasing pressure will favor lower volume. So it will move towards the left. So moves to the left. So for question number 16, C is the correct answer. Question number 17. In which reaction is the underlined compound acting as a reducing agent? Underlined compound acting as a reducing agent. Now we can see carbon dioxide reacting with carbon to produce carbon monoxide. Good question. Now in this question, underline compound. All right. In this question, in here we had the carbon's oxidation state of +4. All right, guys, when this particular, we have to consider it in a different manner. When this particular carbon is going from carbon dioxide to carbon monoxide, if you notice carefully, the carbon had 2 oxygen originally, but it ends up with 1 less oxygen. Loss of oxygen is reduction. So if this particular carbon dioxide is being reduced, then it cannot be a reducing agent. We can only be a oxidizing agent. So guys, on that perspective, A is wrong. For B, we can see the carbon. The carbon is gaining oxygen to get oxidized. Now, whatever gets oxidized acts as a reducing agent. So we already got our answer that B is the correct answer, because carbon gaining oxygen, it is oxidizing itself, and thereby it is the reducing agent. Now let's see why C and D are wrong. In Fe2O3, the iron is going from iron oxide to iron. Now, going from iron oxide to iron is a loss of oxygen. That means it is reduction itself. HCl is going from HCl. All right, calcium carbonate reacting with HCl to produce calcium chloride and H2 and CO2. Guys, in a chemical reaction like this one, there is no change in oxidation number, because this is neutralization reaction between a carbonate and an acid. So thereby cannot be judged with a redox reaction. So 17B is the correct answer. Guys, question number 18. X, Y, Z are oxides of elements in the same row of the periodic table. Some information about each oxide is shown. All right, X is an oxide. It is soluble in water. Can it neutralize an acid? No, so it's not a base. It can neutralize an alkali. Definitely it's an acid. So this is an acid. So if we get A, which is acidic, we already got that this will be the correct answer. So let's see why the rest of the things are, how the rest of the things are correct. Y is insoluble. However, it can neutralize an acid and a base. Definitely this substance having an ability to neutralize an acid and an alkali. Definitely it is amphoteric substance. So we'll just write it amphoteric. All right, slightly soluble Z, ability to neutralize an acid, which indicates that this is a base. It does not neutralize an alkali, so not amphoteric, so basic. All right, A is the correct answer. Question number 19. 4 different acids are dissolved in water. Which beaker contains the most concentrated solution? Concentrated strong acid. Whenever we have to determine a strong acid, it must fully dissociate. A strong acid's properties is acid donates proton, meaning donates hydrogen ion, and strong means ionizes fully. So we can say B did not ionize fully, neither did C ionize fully. All right, in terms of H plus ion, there is 4 H plus ion in D, and there is 1, 2, 3, 4, 5, 6 H plus ion in A. Definitely A is the stronger acid. Question number 19A. Question number 20. The following substances can be reacted together to prepare salts. All right, question number 20. So copper 2 oxide and excess hydrochloric acid. All right, so yes, definitely we can react copper 2 oxide and excess hydrochloric acid, and that will produce copper chloride. However, this is going to produce acidic salt. Hydrochloric acid and excess of sodium hydroxide. Hydrochloric acid and excess of zinc carbonate. Okay, so the question says, in which reaction can the excess reactant be separated from the solution by filtration? Now guys, if we add excess acid, we cannot filter it out. All right, if we add excess sodium hydroxide is soluble in water, cannot be filtered out. However, if we add excess zinc carbonate, we can filter it out. So number 3 only. So D, question number 20, D is the correct answer. Guys, thank you for joining the video. See you in the next video. And if you like these videos like this, and if you like videos like this to be posted in our channel, please like the channel, like this video, subscribe to the channel. All right, and stay with us. Thank you. Bye bye.